morning. This is Kasturi Day. Today, again, I'm going to discuss the physical and chemical change question answers according to ICSE syllabus class 8. Okay, so let me start. Today, I'll start with define physical change and state main characteristics of a physical change. See, it's a physical change is that change that alters some specific property of the matter. Some specific property of the matter is changed without any change in the composition of its molecules. So molecular composition does not change, only specific properties of matter that change. That type of alteration, that type of change is known as physical change. Okay, so the main characteristics of a physical change are that no new substance is formed. No change is there in the chemical composition of the original substance. Okay. Then change is temporary and it can be reversed by reversing the conditions. Change is only in the state, size, shape, color, texture or the smell of some or all of the substances that undergo physical change. Okay, but these changes are not permanent. Okay, and they can be reversed by reversing the condition. No change in mass of a substance takes place. No change, no gain or loss of energy takes place. Okay, so these are the main characteristics of a physical change. Next, we come to define chemical change and state the main characteristics of a chemical change. So first is a change that alters the specific properties of a substance by bringing about a change in its molecular composition. Here, see, the main basic difference between a physical change and chemical change is that the specific properties is changed. Okay, both the cases, but only main difference is that there is a change in the molecular composition in case of chemical change. Okay, followed by a change in the state or in a chemical followed by a state of a change of state that takes place in the chemical reaction, chemical change. Okay, that's a chemical change. The main characteristics are new substance or substances are formed. Okay, the composition of its original substance that changes completely, and totally new substance is formed which has a different composition. Okay, then that this type of change is permanent and irreversible. Mass of the original substance changes. There is an exchange of energy during a chemical change, that is heat and light may be released or absorbed. Okay, next is give two examples which illustrate the evolution of a gas during a chemical reaction. When 2N reacts with sulfuric acid, dilute sulfuric acid, then H2S gas is evolved. This gas burns with a pop sound. Okay, when zinc, sorry, not 2N, it's when zinc reacts with dilute sulfuric acid. When zinc reacts with dilute sulfuric acid, then hydrogen gas is evolved. Okay, so zinc reacting with sulfuric acid, dilute minded, then hydrogen gas is evolved, and that hydrogen gas we can identify by hearing a pop sound when it burns. Then another example is evolution of gas in this chemical reaction, where sodium nitrate, if it is decomposed when it is heated strongly, it liberates, it melts to form sodium nitrite, and oxygen is liberated. How can we find that the gas is oxygen? How can we identify? By taking a glowing splinter near the oxygen cylinder, oxygen gas where it has been liberated, that helps in rekindling the glowing splinter. So that is a confirmation test for oxygen. Now give two examples which illustrate the change in the color of reactants during a chemical reaction. When red lead oxide, that is Pb3O4, red lead oxide, which is red in color, is heated strongly, it forms yellow colored lead monoxide, that is PbO. So what happens? Red color changes to yellow. Okay, and a gas is evolved, that is oxygen is evolved. Okay, another example is when copper carbonate, Okay, copper carbonate, which is green in color, is heated strongly. Then it leaves behind a black residue. What is it? It is black copper oxide. Okay, which is black in color, and it liberates carbon dioxide. So what happens here? Green color changes to black with the liberation of carbon dioxide. Next is illustrate the formation of precipitate during a chemical reaction. Certain chemical reactions are characterized by the formation of precipitate, which is, what is precipitate? It's an insoluble substance. Okay, when the solution of two soluble products, so two soluble chemical compounds are mixed together, when two soluble chemical compounds are mixed together and the reaction takes place, forming an insoluble substance which is known as a precipitate. Okay, for example, a white precipitate of silver chloride is formed when a colorless solution of silver nitrate is mixed with a colorless solution of sodium chloride. When silver nitrate combines with sodium chloride, then what happens? A precipitate of silver chloride, white precipitate of silver chloride is formed. See the reaction, AgNO3, which is a solution, and aqueous solution, and sodium chloride, that's also an aqueous solution, forming a sodium nitrate, that's a solution, and a precipitate of silver chloride. Then a dirty precipitate, another example, a dirty green precipitate of ferrous hydroxide is formed when a solution of ferrous sulfate, that's green in color, is mixed with sodium hydroxide solution, that's colorless. So both the things are in solution, that is ferrous sulfate and sodium hydroxide. These two, one ferrous sulfate is green in color, whereas sodium hydroxide is colorless. So when both of them are mixed, then a green precipitate, dirty green precipitate is formed, which is of ferrous hydroxide, and sodium sulfate is formed, is in solution form. So these two are the precipitates which forms. Then define an exothermic reaction. Support your answer with two examples. See, exothermic reaction is the chemical reactions which proceed with the release of heat energy are called exothermic reactions. For example, when magnesium ribbon is heated from its tip in a Bunsen burner. When we when heat is applied to magnesium ribbon from its tip, then it starts burning into a flame. Okay, it catches fire and it burns with a dazzling white flame. Okay, and it liberates light energy, heat and light energy also when it burns. Okay, and the product that is formed is magnesium oxide. Okay, so this is a example of exothermic reaction because it liberates heat and light energy. So that's an exothermic reaction. Heat energy is liberated. Then another example is when a small piece of quicklime, that's calcium oxide, when it is placed in 100 millimeter, about 100 ml of water. Okay, calcium oxide placed in 100 ml of water, the water becomes very hot and sometimes starts boiling. Okay, you must have seen then when people does coloring in our houses, no, they dissolve this calcium oxide in a tin containing water, so that gives a lot of heat. That water starts boiling. Okay, it is because that calcium oxide that reacts with water to form calcium hydroxide with the release of heat energy. Okay, so that's an exothermic reaction. Now define an endothermic reaction and support your answer with examples. The chemical reactions which proceed with the absorption of heat energy, that is endothermic reaction. Okay, exothermic is liberation of heat energy and endothermic is absorption of heat energy. Now for example, sodium bicarbonate, when it is heated strongly, it swells up to form sodium carbonate. Okay, and steam and carbon dioxide gas is evolved. Okay, but this reaction takes place only on heating. If you only heat sodium hydrogen carbonate, that is sodium bicarbonate, if heat it only, then only it produces sodium carbonate, water and carbon dioxide. So this is an endothermic reaction absorbing heat. Okay. Now give two examples to show a change of state during a chemical reaction. For example, two volumes of hydrogen gas when react with one volume of oxygen gas. That's see, both of them, that is hydrogen and oxygen, both of them are in the gaseous form, gaseous state. Okay. When they combine, they form one volume of water. Okay. Sorry, two volumes of water is formed. Two volumes of hydrogen and one volume of what oxygen, it forms two volumes of water. Okay, that is in the liquid form. So gas converts into liquid, so change of state takes place. Next is ammonia gas reacts with hydrochloric acid gas. See, ammonia gas, again gas reacting with another gas, that is hydrogen chloride gas. Okay, and that these two gases when reacting, they give out a white fume of ammonium chloride, dense white fumes of ammonium chloride, that is in the form of solid state. Okay, fumes of ammonium chloride come out and which condenses to form a solid ammonium chloride. So again here gas state changes into solid. Next, we come to give reasons. Freezing of water to ice and evaporation of water are physical changes. It's so because in the above two changes, see, no, there's the physical state only changes. No new substance is formed. Okay, no change of mass that takes place. No gain of energy or loss of energy that is taking place. So that's a physical change. See, water changing into ice, but the main chemical composition that is H2O. Okay, again evaporation of water into vapor, that is also the main composition, the main chemical composition, that is also water. So there is no chemical composition changing. Okay, no change in mass, no change in gain or loss of energy. So that's why it's a physical change. Again, burning of a candle is both a physical change and a chemical change. See, when we burn candle, okay, some of the wax that melts, okay, that is again if we melts, and that when we cool that wax, then it becomes solid. So that's a physical change occurring. Okay, but some of the wax that burns, when the flame is burning, it burns and it converts into carbon dioxide and water. And if we combine that carbon dioxide with water, we will not get back the wax. So what happens? That means carbon dioxide and water vapor that comes out, that is a totally new substance. That those are the totally new substances which are formed from the wax. So that's a chemical change taking place when the wax is burning with the evolution of light and heat. Okay, so that's a chemical change. But when wax is melting and again solidifying into wax, that is a physical change. So both the changes are occurring in the burning of a candle. Then burning of a paper is a chemical change, because when we are burning a paper, it changes to ash. Okay, but when we stop burning, we will not get back the same paper. So there's something new substances form. That change is permanent, not not reversible. Okay, and change in mass also takes place. Then again, cutting of a cloth piece, that's a physical change, because the main composition of the cloth, that is the that cloth, that remains the same. Chemical composition remains the same even if you cut into small pieces, but it remains the cloth. Mass also, if you together, you all the bits of cloth, if you combine, the mass remains the same. So there is no change of mass, no change of no loss or gain of energy takes place. So that's a physical change. So this is the end of this chapter. I'll start with a new chapter in my next video. Please go through this. If you have any doubt, please do let me know. Please do write in the comment box. Okay, it will be element, compounds and mixtures in my next video. Okay, so go through the chapter, the text portion, as well as the video, the question answer series. If you have any doubt, do write in the comment box. Do press the like button so that I can be enthusiastic to it will grow some enthusiasm in me to give you some more good videos for you, and also that will help you to learn more better things. Okay, So do subscribe to get the notification of my next video. Thank you for watching and have a good day.